Hi, welcome back. The problem today is about the equation that combine between the radical and the trigonometric equation. Now, let's get started. We rewrite the equation that we square root of 1 plus 2 cosine x plus square root of 1 plus 2 sine x equal to square root of 3. So we do the natural approach here. Just square both sides of the equation. That we will have the 2 plus 2 sine x plus cosine x plus 2 square root of 1 plus 2 sine x plus cosine x plus 4 sine x and cosine x equal to 3. So simplify that, we will have the 2 sine x plus cosine x plus 2 multiplied by square root of 1 plus 2 sine x plus cosine x plus 4 sine x cosine x minus 1 equal to 0. So then we can see that the left hand side that consider the sum of the sine x and cosine x, and another expression is the product of the sine x and cosine x. Then we can remember about the way we put the substitution, that we have a equal to sine x plus cosine x, and the domain of x is smaller than square root of 2 and greater than negative square root of 2. So, and we have the sine x plus multiply cosine x will equal to a squared minus 1 divided by 2, because we have sine square x plus cosine square x equal to 1. So that's a very famous formula in the trigonometry problem. Then we rewrite the equation by this substitution, that we have 2a plus 2 square root of 1 plus 2a plus 2a minus 1, a square minus 1 equal to 0. Sorry, minus 1 equal to 0. Then we move the expression which have no radical sign to the right and keep the other with radical sign on the left. And we have 2 square root of 1 plus 2a plus 2a squared minus 1 equal to 1 minus 2a. So then we just put another extra condition of a here. We have 8 is on the left side is on greater equal than 0, and on the right hand side then we should have the same thing. It means 1 minus 2a also greater equal than 0, and a has to be smaller or equal than 1/2, it means we rewrite the domain of H here, that is negative square root of 2 and 1/2. So that is the new domain of H. That is the important step we have to consider before we do the next step is square both sides of the equation 1. Then the next is square both sides of the equation 1. We have 4. 1 plus 2i plus 2i squared minus 1 equal to 1 plus 4i squared minus 4/8. Simplify this equation, we have a squared plus 8a squared plus 8 and plus 2 sorry, this should be minus 4, sorry, and equal to 1 plus 4a squared minus 4/8. And simplify both sides and move it to 1 and the other should be 0. Then 4a squared equal to plus 12a minus 5 equal to 0. Then you will see this is very simple quadratic equation that we can to apply the formula of the root of quadratic equation into the equation 2. Then we have a would be equal to square root of 14 minus 3 over 2 or 8 equal to negative 14 minus 2 over 2. Then we will receive the first root only. For the second root we reject it because when we compare with this one, the domain of 8, the first one, only the first one is belong to the domain, so we receive the first root. Then when you have it, it means sine x plus cosine x equal to square root of 14 minus 3 over 2. And on the left side, you probably can do the basic form of the expression. You will transform it into x minus pi over 4 multiplied by square root of 2. That's a very basic transformation. If you don't know how to do it, I will explain it a little bit for you below. So for sine x plus cosine x equal to square root of 2 multiply sine x 1 over square root of 2 plus cosine x 1 over square root of 2. Then it will equal to square root of 2 multiply sine pi over 4 multiply sine x plus cosine pi over 4 cosine x. Then this is the very famous formula in the trigonometry problem. Then it will become cosine x minus pi over 4. Then we have cosine x minus pi over 4 will be equal to square root of 14 minus 3 over 2 square root of 2. Then it means x minus 4 minus pi over 4 will be equal positive or negative inverse of cosine. This one, it means this one plus k to pi. Then again, x will be equal to pi over 4 plus or minus inverse of cosine square root of 14 minus 3 over 2 square root of 2 plus k to pi, which k is a member of integer. So that is the final result of the equation. But the lesson from this equation is, first thing, we come with the natural approach that just square both sides of this. Then we recognize the connection between a few expressions inside the equation. In this case, we have sin x plus cosine x and sin x multiplied by sin x. And we put the substitution variable, and they will have the connection between expression as I explained. Then replace the expression with x by the substitution variable into the equation. Then we will simplify and convert it into the basic quadratic equation. Remember, the important thing is about the domain of substitution variable. The next is check the root of the equation to satisfy the domain of the substitution variable. Replace it back to the expression. Solve it by simple problem. Then receive the x value as we need to find in the problem. So that's it. Thanks for watching. See you later. Bye.